Alright guys, so today we're going to start on derivatives. So derivatives is a way that we can find the instantaneous rate of change at any one given point. We're in our notes packet, but I want to explain where the formulas come from. If you look at your notes packet under section 2.1 part 2, it's called using limits to find derivatives. So the derivative finds the slope of the tangent line to the curve at any point. So it's finding the slope at just one point. We don't need 2 points like we normally do. We can just do it at 1 point. These are some common symbols that are used with differentiation. You can see f prime of x. That means to find the derivative. dy dx. That means to find the derivative. Y prime. And d dx of f of x. All of these are symbols that mean the same thing. At the college level, calculus can be confusing because, you take Calc 1, they use this form of the derivative. You take Calc 2, your professor always uses this. And it can be confusing. So you just need to know from day one that all of these mean the exact same thing. Find the derivative. Here are the limit definitions for a derivative. Right here and right here. We can either use a delta x when we do this, or we can use the letter h. Now, I really want you to understand where these formulas come from. These formulas are very difficult to memorize unless you understand where they come from. So we're going to go off here to the side, and I just want you to watch and see where these concepts came from. So let's say that I have some polynomial function. And let's say that I'm trying to find the slope right here at this point. Well, I can call this point x, f of x. I don't know exactly what it is, but I know that I can, if I have an x value, I'll just plug it into the function to find out what the y value is. So if I want to find the slope right here, well, I really have to have 2 points. So I'm now going to look at this point. This point is x, but it's a little bit further over. So I have to call it x plus delta x. Well, if I call this point x plus delta x, the y value is going to be f of x plus delta x. So I'm really starting with these 2 points. How do I find the slope between 2 points? What's the formula? How do we find slope, David? Remember, you're doing distance. Slope is y sub 2 minus over. Good. So that's how we find slope. So look, guys, this is our first x. This is our first y. This is our second x. This is our second y. So if I want to find the slope between these points, I say the slope is going to equal this second y minus my first y, and then my second x minus my first x. You see what I'm doing there? All I'm doing from the beginning is I'm saying if this is an x, this is another x that's very close to it, but it has a change in x. That's why I call it x plus delta x. So once I get all these points set up, I just do y2 minus y1 over x2 minus x1. What's going to happen in the denominator here? Yeah, David? Yep, the x's cancel out. So right here is my formula for slope. And right now, it's between 2 points. That's telling me the slope between these 2 points. But if I want to find the slope at just 1 point, I want this point to really be the same as this one. If I want this point to be the same as this one, what is it I want the delta x to be? How much do I want to have added on to x if I want it to be the same thing? Right, some of you are saying it, 0. So that's why we have to have the limit as delta x approaches 0. Because I want the change in these 2 x's to really be nothing so that I can find the slope at 1 point and not have to have 2 points. That's where this formula comes from. And this is the most basic derivative formula we have. It's where we start with derivatives, is we use limits to find the slope or the rate of change at one point. Because if I have 2 points, but if the change in x is 0, then I really just have 1 point. Because if the change in x is 0, then the points are right on top of one another. Now, sometimes people choose to use the letter h instead of using delta x because they just forget what delta means and they just get confused with it a little bit. So if you want to use h's, you can. I'm going to switch back and forth because some of you, when you go off to college, your professors are going to use delta x, some are going to use h, and I want you to just be familiar with both of them. All right, so back over to our actual notes. These are the formulas. This is the most important thing. You don't have to have it memorized right now, but you will by the time we have our next quiz. You'll have to know this, just both forms here. All right. So in the first problem, it says to find f prime of x. F prime of x means to find the derivative. So we have to say f prime of x is going to equal the limit as delta x approaches 0. Now, to do this, I have to do f of x plus delta x. That means in this function, wherever I have an x, to do this right here, I have to replace the x with x plus delta x. So, right here's my x. Everything stays the same. The 5 stays the same, but this is now going to become x plus delta x minus 4. Right here. This is just this part of the formula. Now I have to do the next part of the formula. It's like I'm going back and forth. So now I have to do minus f of x. Well, what's f of x? It was given to us. What is this? 5x minus 4. So I have to do minus 5x minus 4. And now I have to do all over delta x. So this is my problem. This is my setup that will tell me the derivative of this function. So now I'm going to finish. So I have the limit as delta x approaches 0 of 5x plus 5 delta x minus 4, distribute this negative through, minus 5x plus 4 all over delta x. So now I look at this, and a lot of things should simplify down and should actually disappear. 5x minus 5x, that cancels. Negative 4 plus 4, that cancels. My whole goal is to plug in 0 for delta x. But if I do that right now, I'm going to get 0 over 0. So I have to do more work. So right now I have 5 delta x over delta x. Delta x is just one value by itself. I can cancel them out. And my answer is 5. Can anybody explain why it makes sense that the derivative is 5 based on what I've been saying about what the derivative does? David? Exactly. Right here, this is just a linear function. This is really the function, y equals 5x minus 4. It's linear. The slope is 5. The derivative is going to be 5. Okay? We could have saved ourselves all this time just by recognizing that. So anytime you have a linear function, the derivative is just going to be equivalent to that slope. And you're going to have a worksheet today, and you can do that on any linear function. So you might want to put a little star next to this just so you remember. Linear functions, the derivative is the same thing as the slope. You don't even have to go through that work. But, of course, that's going to be pretty rare that we're going to be given linear functions. So, let's look at number 2 now. We're trying to find the derivative. So I say y prime equals. This time I'm going to use the h. It doesn't matter. I can use either one of these. I just want you to be able to use either one and understand that it's the same process. So to find the derivative, it's the limit as h approaches 0 of f of x plus h. That means I have to look at my function, and wherever I have an x, I have to replace that x. What do we replace the x with? X plus h, right? So now this part of the function is going to be 2 over, here's my x, x plus h, minus, I'm working back and forth, f of x is right here, f of x is the same thing as y. So f of x is 2 over x, all over h. All right, so here's what we have. We have done limit problems like this before. We have to get rid of this denominator. So what I can do in one step, I can get rid of that denominator by multiplying by x and x plus h on the top and on the bottom. I'm multiplying through by that common denominator. So I still have the limit as h approaches 0. When I multiply here, what am I going to end up with if I have 2x, x plus h over x plus h? What are we just going to end up with? What is it, everybody? 2x. Good, because the x plus h is canceled. So I'm just going to have 2x minus, now I have to multiply this one. What am I going to do if I have 2x, x plus h over x? What am I just going to end up with? Minus 2 times x plus h, right? So it's minus 2, because these would cancel on this term. So I'm just going to have minus 2 times x plus h. On the bottom, I'm never going to multiply out the bottom. I'm just going to leave it. It's xh times x plus h. Here are some of the bad algebra mistakes I see people make. People cancel these x plus h's. You can't do that. This is part of this whole term here, so it has to be distributed first. You can't do any simplifying on this step. We want to plug in 0 for h, but if I do that, I'm going to get 0 over 0. So I have to simplify. So I'm going to have 2x minus 2x minus 2h over xh times x plus h. All right, so now we're going to look at what happens. If I have 2x minus 2x, that's going to be 0. So now I've got the limit as h approaches 0 of negative 2h over xh times x plus h. So now my h's are going to cancel. So now, once these h's are gone, I can finally plug it in. So y prime is going to equal. My h's are gone, so now I can plug in 0 for h. What's that going to leave me with if I plug in 0 for h? Andrea, do you know? If I plug in 0 for x, for h, what am I going to be left with? X squared on the bottom and what on the top? So the derivative then is negative 2 over x squared. That's the function that would be the derivative of that original. So what this derivative does is now I could plug in any x value and it'll tell me the slope of the tangent line to the curve of this at any given point. I can just plug in and find that slope. All right, let's do this one now. This looks a lot more complicated, d dx of g of x. It's not. It still just means to find the derivative. So I have to find this derivative, so I'm going to be working back and forth with my formula. You can either use the delta x or the h. I'm going to use the delta x on this one, switching back and forth. So I'm going to say then, I'm just going to call this g prime of x. That means the same thing. So I go up to my formula. It's the limit as delta x approaches 0. Wherever I see an x in my function, I'm doing this right here, f of x plus delta x. Here's my f of x. So in this x function, wherever we see that x, we have to replace that x with x plus delta x. So I'm going to have x plus delta x cubed plus 2. Don't forget the plus 2. People always forget that. Minus f of x all over delta x. Guys, you have to be able to cube this out. So you have to multiply this out. You can't just do x cubed plus delta x cubed. So I have to do x plus delta x times x plus delta x, get that answer, and then I have to multiply by x plus delta x again. So when I multiply this out, I'm going to get x squared. I'm going to get x delta x plus another x delta x, so that's 2x delta x, plus, and then I have to do the last times the last. So that's plus delta x squared. And now I have to multiply it again by x plus delta x. I'm cubing this out. That's all I'm doing is I did it twice, now I have to do it again. So now I'm going to have x cubed, I'm going to have an x squared delta x, I'm going to have a 2x squared delta x, I'm going to have a 2x delta x squared, I'm going to have an x delta x squared, and a delta x cubed. I just did that off to the side. So I've got the limit as delta x approaches 0. When I cubed all this out, I'm going to get x cubed, done with that. Here's an x squared delta x, and here's a 2x squared delta x, so that gives me 3x squared delta x. So those are gone. I go to my next term, I have 2x delta x squared and x delta x squared. So that's going to give me a 3x delta x squared. And then I have plus delta x cubed. So all of that is just what I get when I have x plus delta x cubed. That's what it turns into. X cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. That's just for this. Write the rest of it. Plus 2 minus x cubed minus 2 all over delta x. Guys, I would memorize how this cube goes because it's a real pain to multiply it out. Look at the pattern. What do you notice in the pattern for these coefficients? It goes what? 1, 3, 3, 1. Look at the exponents. It goes x cubed, x squared, x, no x. Look at the delta x, the second term. No delta x to the first, delta x to the second, delta x to the third. Have any of you learned Pascal's triangle in the past? Yeah, Pascal's triangle is a way that you can do that. See, look, anything to the 0 power is just 1. Then you have anything to the first power, anything to the second power, anything to the third power. So anything we do to the third power is going to have coefficients of 1, 3, 3, 1. The powers have to go x cubed, x squared, x, no x, delta x, no delta x to the first, delta x to the second, delta x cubed. Okay? So if you can use Pascal's or just multiply it out, you're going to be in good shape. All right, let's finish now. So we have the limit as delta x approaches 0. I want to plug in 0 for delta x to get those 2 points to be infinitely close, but I can't right now because I'm going to get 0 over 0. But if I look at x cubed minus x cubed, that's 0. 2 minus 2, that's 0. So I'm left with this now. What do all of these have in common that I could factor out? What do they have in common, guys? David? Delta x. So I'm going to take out a delta x, and I'm left with 3x squared plus 3x delta x plus delta x squared all over delta x. So do you see now how we can cancel out these delta x's? After that delta x in the denominator's gone, now I can plug in 0 for delta x. So I can plug in 0 here, I can plug in 0 here. Plugging in 0 for delta x. So what's my answer going to be then, guys, for this derivative? Lauren, do you know? If we plug in delta x as 0, so we plug in 0 here, plug in 0 here, what's the answer? 3x squared. So that's going to be our derivative on that problem. Questions? All right, let's do the last one. We can use either delta x or h. Let's go ahead and use h on this one. Let's practice that. All right, so find dy dx. That's just saying to find the derivative given y equals this. I'm going to go ahead and call it, I'll call it dy dx. So dy dx is going to equal the limit as h approaches 0. Here's my function. Wherever I have an x, I look at my formula. I have the limit as h approaches 0. I've got that part. I go to this part. Wherever I have an x, excuse me, I'm going to replace it with x plus h. So I've got radical, here's my x plus h plus 1, minus f of x. F of x is just y. So that's radical x plus 1 all over h. There's our formula. So to find this derivative, we have to be able to simplify this. Does anybody remember how we simplify a limit if we have two radicals in the numerator? Multiply by the, David? Conjugate? Yep. Conjugate. When I do the conjugate, I write the exact same thing, radical x plus h plus 1, but I change this middle sign to a, if it's a minus, I make it a plus. And if I do that to the top, I also have to multiply by that on the bottom. So I'm multiplying the top and bottom by the conjugate of the numerator. So now I'm going to have dy dx equals the limit as h approaches 0. I only multiply out the top, guys. Don't multiply out the bottom or it's just going to make it worse. See, we want to get rid of this h. That's what's causing us to get 0 over 0. So we want to leave it out there. If you multiply it out, you're just going to have to unmultiply it in the beginning. What do we get if we multiply two radicals and they're exactly the same? What happens? Casey, what happens? Right, the radical just goes away. So if I multiply these two things, I'm just going to have x plus h plus 1. When I think about doing these outers, I get a positive of those two values. When I do the inners, I get the same thing, but it's a negative. So those two are going to just give me 0. Now, be careful here, guys. Everybody watch closely on this. When I do the last times the last, it's going to be minus, but you cannot just put x plus 1 like that. What do I have to do with this x plus 1, David? Not really. What I have to do is it's minus this quantity. So if I do a radical times a radical, I just get what's under the radical, but I have to use parentheses under it, around it. Because, yeah, eventually I'm going to have to, you were just thinking ahead. Yeah. So that's what I get when I FOIL out the top. On the bottom, I don't do anything to it. I just leave it alone. Just rewrite it. So now we've got this. Okay, so then on this one, we're going to have x minus x. Those are going to give us 0. We have 1 minus 1. That's going to give us 0. So now we just have h over h times all of this. Okay, so now I can cancel these h's. So now on the top, what do I have left on the top, everybody? Just 1, right? Because I canceled. And so now I can plug in my h equals 0 now. I've been wanting to do that, now we can do it. So now we're just going to have this derivative, dy dx, is equal to 1 over, if I plug in 0 here, I'm just going to have radical x plus 1 plus radical x plus 1. So I'm going to have 1 over, and if I have radical x plus 1 plus radical x plus 1, what are we going to end up with? Chris, do you know? Good job. And that's going to be that derivative. Okay? Questions? It's not that difficult, guys, but you really have to just make sure that you practice it, on the worksheet, and then once you do it a couple times,